Have you ever wondered how our universe will die? Scientists suggest several possibilities for this distant event. For example, the Big Rip theory says that after billions of years, the universe will simply run out of fuel. This means that all sources will be exhausted, evolutionary stages will come to a standstill, and gravitational couplings will dissipate. Thus, there will be a heat death, the result of which will be a gradual decomposition of the macrocosm into atoms and smaller particles. Galaxies, stars, and planets will cease to exist, and the universe will turn into a mega-desert where none of the known laws of physics works. Not a very optimistic ending, is it? Don't be sad, there is another option for the end of all things, the Big Crunch. It is opposite to the one described above. If the expansion of the universe does not accelerate but on the contrary slows down, all objects and systems will inevitably begin to approach each other. I wonder how this is going to happen, and will the process have an effect on black holes? If so, what will happen when all the black holes in the universe collide? Sit back and let's try to visualize this nightmare scenario. First, let's define how and why black holes merge. Space is a unique place. Despite the many objects in it, they are very far away from each other, so approaches and collisions are quite rare. As for black holes, the situation is even worse. These space objects are extremely rare. Therefore, such contacts are exclusive, and their recording is considered a sensation by astronomers. But still, black holes periodically coalesce to create something new, more massive and terrifying. Invisible spatial vortexes can collide in two cases. The first one involves binary star systems of enormous mass. If two huge neighboring heavenly bodies, each hundreds of times more massive than the Sun, begin to collapse after using up their fuel, new black holes are almost always created in their place. Naturally, under such conditions, sooner or later, they will collide. The second scenario is less obvious. If one of the black holes born in different corners of the universe loses potential energy due to spending it on gravitational acceleration of any objects or attracting matter, it gradually begins to shift towards heavier structures, clusters of galaxies, or to the center of its own. There, the traveler usually encounters a stationary black hole. Have you ever seen a major car accident? A train crash that collided head-on? Perhaps you witnessed a plane crash. Well, all of these events, combined with the explosions of hundreds of neutron bombs, the eruptions of supervolcanoes, and the rampage of raging tornadoes, cannot even remotely serve as the equivalent of the power of the merging black holes. The scale of this universal collision is difficult for a human to imagine, but we will take the risk. The energy released by the contact of two average-sized black holes is approximately equal to the immediate explosion of a quintillion stars. But what if this is just our imagination and such an event is impossible? The LIGO Gravitational Wave Observatory recently provided the world with hard evidence that black hole collisions are an undeniable cosmic reality. Sensitive instruments recorded a monstrous perturbation from the colossal explosion, compared to which previously recorded waves are like the difference between a light breeze and a tsunami. Astronomers call such events time capsules because they carry a lot of encrypted information about the past of the universe. After all, sometimes waves of collisions that occurred before the beginning of time reach Earth when there was not only the solar system, but also the Milky Way as a whole. For example, scientists recently caught the leftovers from phenomena of the catastrophe that happened about 5 billion years ago. But let's return to the question posed at the beginning of the video. What would happen if absolutely all black holes of the macrocosm collide? What can cause such a mega cataclysm, and is it actually possible at all? Let's say it once. In theory, yes. The Big Crunch, as one of the variants of the death of our universe, involves a gradual but unavoidable slowing down of the expansion rate of space-time matter by reducing the amount of dark energy up to complete stop of this process. After that, according to fundamental laws, gravitational force will become dominant and compression will begin, but there will be no immediate collapse. The universe will shrink fivefold, and during this period, there will be no distant galaxies left. The macrocosm will be filled with one cyclopean cluster, within which the usual evolutionary processes will take place: birth and death of luminaries, and even the development of biological life. But it is still the beginning of the end. It should be understood that the merger of galaxies into one cluster at this stage does not necessarily involve collisions of planets, stars, or black holes. Close contacts are unlikely to occur due to the huge distance of objects from each other and the low concentration of matter, although isolated cases are not excluded. To realize how galaxies will merge into one, it is more logical to turn to the event that astronomers prophesy to us in 4 or 5 billion years, the merger of Andromeda and the Milky Way, with the appearance of Milkdromeda. It is believed that nothing super epic will not happen. Moreover, from Earth, the consequences of this event will not even be noticeable. Although there is a possibility that the solar system will be thrown out of the new galaxy, turning it into an eternal wanderer, and the holes in the centers of Andromeda and the Milky Way will merge into a single, supermassive monster. Although, of course, this example is not equivalent to the Great Compression scenario, since billions of structures will not be involved. So what happens next when the universe becomes 100 times smaller than it is now? It will no longer be a cluster, but a single galaxy of monstrous size. That's where the fun begins. The macrocosm will heat up. The temperature of the significantly thickened relic radiation will reach 274 Kelvin, because of which the ice caps on the rocky planets will begin to melt. A little more, and the background light of the universe will eclipse even the central luminaries of star systems. That is, it will turn into a giant fireball. Billions of black holes will come into action, hitherto sleeping in the centers of galaxies and in the backyards of the macrocosm. Imagine how they systematically devour matter, crushing objects first into atoms and then into protons and quarks. The funnels will merge with each other en masse until, in the end, they will become one global black hole, which contains the power and weight of decillions of members of the universe. The merger of all things into a super-mega archimassive monster will lead to unthinkable consequences. The object will swallow itself and collapse into the abyss of singularity. As they say, from nothingness you emerged, into nothingness you will go. Will everything happen again in the strange, chaotic space left in the place of the former universe? Scientists have accumulated a huge number of theories on this subject. One of them is related to the controversial concept of the decay of the false vacuum. In quantum field theory, the vacuum is the state of the field with the lowest energy level. So imagine there are two states, false and true vacuum, and under unfortunate circumstances, this false vacuum can simply spill out and start uncontrollably replacing the true vacuum. At that, a gigantic amount of energy will be released, which of course will destroy the universe as we know it. However, the key here is the idea that after the complete replacement, a new universe can be born from the false vacuum. The natural conclusion is that after the previously described Big Bang, a new transition from the false vacuum to the ordinary vacuum is possible. Be that as it may, on this and many other questions of universal scale, modern science cannot answer because in conditions of death of the universe known to us, laws of physics are useless and therefore any predictions are impossible. But it certainly does not mean that we cannot make our own forecasts and assumptions. That is what we are encouraging you to do. Remember that your thoughts will shape our reality in the future. Subscribe if you haven't already, and share your thoughts in the comments. Everyone will be understood and heard on our channel, and the number of likes will show how much you are interested in this topic. If the likes pass the threshold of 20,000, we will try to release a sequel where we will introduce you to even more interesting facts about modern science.